Now. Hey everyone, welcome to the Weekly Space Hangout for Friday, February 12th, 2016. I'm Fraser, Cain, publisher of Universe Today. With me this week, we've got a special guest we'll get to in a second, but one of our regulars, we've got Jolene Creighton from Futurism.
Hello, Fraser
Hey,
and everyone. Hey.
We got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
Right on. And our special guest is Shira Teitel, who a couple of months ago was our guest, and she told us she was working on a book, and we said that when it was time to shamelessly self-promote your book, when it's published, you should come back on the show and do so. Amy, welcome back.
Hello, thank you for allowing me to shamelessly self-promote myself.
I can't wait to help you shamelessly self-promote this book, because I know it's a long time coming. So I just want to remind everybody that this is a live interactive experience. We're glad to talk to you, and the way to do that now is to use the YouTube chat functionality. So wherever you're watching this on the YouTubes, I'm not even sure how. Go to YouTube if you watch the live. Ooh, can't have that happen. Where you're watching this live, you can go to the YouTube channel. There should be a place to find the chat. I honestly don't really know how this works. We're brand new. At least we made it work this week. So
at least you're honest about it.
I am at least honest about it that I tend to use things before I deeply understand how they work, and that's just how we roll. But anyway, there's a great chat, and what's great is the panelists also jump into the chat and chat with you when they're not actually talking in the show. So it's great. It's a great interactive experience. Cool. So we got a bunch of big stories this week. Obviously, we're going to be talking about LIGO and the discovery of gravitational waves, a man struck by a meteor in India or not, what's happening with NASA's budget, the update on the James Webb Space Telescope's mirror, Asteroid Retrieval Mission, and a whole bunch of hidden galaxies. But before we get to all those other stories, we are going to start and interrogate our special guest. So, Amy, have you done anything recently?
I'm just going to sit like this for the next 10 minutes. So the big thing that I've done recently, actually, it's funny because I haven't done this recently at all. I finished this manuscript almost a year ago, and it just takes so long to have a proper book come out that it's sort of it actually feels a little bit weird, because to me this is I've moved on to other projects. I'm oh yeah, I still need to be talking about this and stop hawking it and shamelessly self-promoting it. So this is my book. It is finally a real book. It's pretty. I don't know.
What is this book about?
You go. Okay, so it's called, as you can see, it's Breaking the Chains of Gravity, the Story of Spaceflight Before NASA. So basically what it is and what it does, everybody here watching this, obviously you're space nerds. We know about NASA, and we know the history of NASA, and we know a lot about, particularly, the moon landing and Apollo era, but there's kind of this weird misconception, I think, that's propagated by the sort of overly simplistic popular narratives where it's Kennedy said, let's go to the moon, and NASA was rah, and then Neil Armstrong was one small step, rah, and then everything was wonderful. But NASA was not created in a vacuum in the late 50s, and it wasn't just this sort of random decision. The roots of spaceflight go back really far, and you can take it. There are arguably very different points that you can kind of begin the story of spaceflight. I began in May 17th of 1930 with a very grisly death because the kicker of an opener. So what this book really does is goes through the history of the development of rocketry, liquid propulsion, space planes, spacecraft, astronaut training, and sort of human factors involved in spaceflight, and the bureaucracy and kind of the political understanding of what you need to have a space agency that works, and how all of these pieces actually existed. I focus, it's NASA, so I focus in America, how these pieces kind of came to be in America, how they all developed, such that when in 1958 President Eisenhower said that we need a national space agency that's civilian-based, not military-based, all of the pieces were there. It was just a matter of smooshing them together under this new umbrella of NASA. So it ends the day that NASA was created. So it's really going back to kind of helping understand where the roots to all of these things that NASA's doing now and the sort of history of NASA that we're familiar with, where it all really started. And I should say, it is super narrative. There's no math. So if you're like me and you can't math but you love this history, it's really written with like a narrative so that there's a story and a flow to it, and it was fun.
I'd like to talk about the research process for doing this book. Where did you go and who did you get to talk to? And what dusty archives did you get to dig through?
Not as many as I would have liked to have, in part just because of the funding element of writing a book. It is a very costly process, and I didn't have an advance, and I kind of had to fund a lot of it. So I got to what I could, and I really relied on the kindness of archivists to places that I wasn't able to travel to. And a lot of people, I knew very specifically the documents that I wanted. So let me back up a little bit. So I kind of started with like with anything when you're doing anything, I kind of started looking at kind of the bigger picture stuff and looking at kind of the overall program histories and stuff. And there would be little things that would kind of stick out to me in a recount or something. But like, oh yeah, there was this memo said something about this. I'm like, I would like to see that memo. So luckily for me, a lot of this stuff has been digitized, and I was able to get it. So a lot of old reports, a lot of like the really important memos, especially like anything presidential has of course been archived. So I was able to find a lot of that stuff. Anything that I wasn't, I would just put calls or emails into archivists at like the Army historians or anybody who was working at a certain site to see if I could get a copy of these things. And for the most part, if they were small enough, people were very lovely about scanning it and just emailing me a copy as opposed to me spending $2,000 to fly out and photocopy a single page. So that's kind of how a lot of that work got done. But a lot of it is just reading a lot of old program reports, and so much of it is military, so much has been archived. So it's just kind of I finally put them away, but I got any of the PDFs that I read, I had them printed in spiral bound because I can't read on a screen, and I probably have a stack of it, well, you can't see it, but like half the size of me, so like 2 feet. Probably like a 2 or 3 foot tall stack of stuff that I had printed from archives, not to mention all the books, all the, everything I had. So it was really just a matter of kind of going through the histories, going through the programs, and then if something seemed like they keep mentioning this report or they keep mentioning this meeting, let me see if I can find minutes to this meeting. And usually there was enough references in sort of like if I couldn't find the minutes from that meeting, the minutes from that meeting were wrapped up in like some program report, and that that kind of gave me the firm grounding I needed for that. But a lot of times I was able to find some of the weird stuff. I did go to the National Archives for 3 days though. That was fun. Not useful because everything I wanted was still classified, unfortunately, because it's all DoD stuff.
So did you go through the process to try and get anything unclassified?
I did. I submitted like 8 FOIA requests, and they all came back saying you can't have it. And I'm not totally sure why. And I think part of it was I was looking for certain proposals that I didn't actually know where they were. I had the date range, the agency, or the military branch, and I kind of knew what I was looking for. I just didn't really know where to look for it. So when I was at the National Archives and submitted the request, and they said, here's this box has this stuff in it. Like, I really want to look through the date range, and the place is exactly what I want, but it's classified. Okay, well, let's see if I can get the FOIA request to look at it, and then it was, well, there's still material in there that you can't see. So it was sort of this, like, it was like chasing something that might not have existed, where it was like, I want that, but I don't even know if it's in there. And a lot of the stuff, you hear about engineers, at the end of the Apollo program, where it was like, all right, clear out your desk, we have no money, go. There's the stuff that just doesn't exist anymore. So what you end up with is the sort of, these notes being referenced in a program history that maybe those notes don't exist. So, yeah, so that was fun.
And I would also, so I'd love to talk a bit about the history, the part that you really did a lot of your work on. What were sort of the big, I don't know, like the forks in the road? Which are the places where the future of U.S. human spaceflight really got defined? I think about Goddard with his original rocket design. I think about when the Americans picked up the Nazi scientists and Wernher von Braun. What were some of these big moments that if they hadn't gone one way or the other way, then we wouldn't have, you wouldn't have the manned spaceflight program that you have?
Yeah. I think the big one that stands out to me, and I feel like I should come out and say this because anybody watching this who's actually read the book is like yelling at me because Goddard isn't in it because he was so reclusive and kind of did his own thing and it's hard to work him in. He was important, I get that. But I think in terms of the people who are like super important and kind of pivotal and kind of at least the again, the story is massive. The story that I think is kind of the most direct and the most pivotal, in a lot of ways, is really getting the German engineers into the United States after the Second World War, which is such an interesting thing to deal with. I mean, not like as a young writer who is also a Jew. Like, it's really, really hard to talk about Nazis in anything that's not like a deeply negative light, and also not apologizing for war crimes while understanding the technology. And that was a really interesting challenge that I really hope I managed. And so far, people aren't whining about it too much. But I think that was kind of one of those moments that if that technology and technological understanding hadn't made it to the U.S., there wouldn't have been as quick an advance in liquid rocketry in the country as we saw. And I think that probably goes for the Soviet Union as well. I mean, they recovered a bunch of Germans. They were able to kind of use that knowledge and use that technology to build the rockets that launched Sputnik and Gagarin and kind of get their whole program, knee slapper, off the ground. So that really does strike me as kind of one of those pivotal things where if Hitler had gotten his way with the scorched earth policy and said, burn everything, nothing from Germany gets into enemy hands, including the scientists. I mean, I don't know what might have happened. I mean, there were other rockets, there were other countries developing this technology, but none really made the advances of the German army at that period. And I think it would have taken us a lot longer to leave the Earth had we not had this brain-based split between these two superpowers who then fought against each other to do it first.
Yeah, that's the part that's just amazing, right?
Yeah.
Is that they really they split up the kids, and then had them. I don't want to take this analogy too far, but but then had them race against each other. That's crazy.
Mm-hmm.
And so I guess you didn't have both those German scientists get separated into those two camps on the American side and on the Russian side, and then have those two camps really try to compete with each other.
Mm-hmm.
Might never even have gone to the moon. Might not have a space station right now. Who knows what it would be like.
There were people who wanted space stations. There were people who were working towards space flight. I mean, this was a thing that was happening. It just wasn't. The technology was so far behind the sort of understanding of the science and the technology that it would have been hard to develop it without having, the people who really started to harness the power, because again, they had so much funding. Without having that to really kind of bring it into reality, it would have been very different.
How much of a driving force was the military? I mean, I think that we think about spaceflight today, and we recognize that there is a military component, but a lot of it is like we just imagine, people jumping around on the moon and floating around in space. But how much of a role is the military in getting this whole thing off the ground? Knee slappingly said.
I mean, it basically was the military for a really long time, because there wasn't. I mean, the civilian agency involved was the National Advisory Committee for Aeronautics, which was as the name suggests, an aerospace or an aeronautics rather. Thank you. An aeronautics. It's the precursor to NASA, basically, and it was just basically about trying to understand how to make better airplanes. And it was founded to try to help the U.S. catch up to developments in flight seen in Europe during the First World War. So the NACA was really good at sort of doing the wind tunnel work to understand how these things were going, but this wasn't. They weren't developing rockets the way the military was. Like when the Germans that were imported into the U.S. after the Second World War arrived, and they brought something like, I forget how many off the top of my head, but like 30 trains full of recovered bits of V2s, and I think 1 or 2 complete V2s that couldn't be fired. But all this technology, it didn't go to the NACA to let's understand the technology. It was like it went to the Army and it went to the Air Force, but mainly the Army, because also the Air Force wasn't separate until 1947, but they took some of it. But the Army would work with the NACA to get some of the sort of supersonic data, but it was really just driven by the military to understand this. And there is a report, the Army Air Force's Science Advisory Group. So Hugh Dryden was part of this group, who was the first deputy administrator of NASA, writing about the need to understand this German missile technology had to be with the military, because the next war would be started and potentially ended by rockets. So they knew in the 40s that this was kind of the next wave of technology, and that the next war was going to need this technology. So getting a jump on it sooner rather than later was kind of the ideal, and that's kind of where like it just all became military. And even like, you know, sticking rocket engines into planes to understand piloted, whether or not you could have a piloted space plane to drop bombs, that fell under the Air Force once it was a separate military branch. And even the Navy started developing its own rockets, and some of it was sounding rockets for research to understand the environment through which the rockets would fly to bomb people, but it was all military.
And even, you know, today, I mean, we get these little glimpses, like when we've got the space, you know, the Air Force space plane. We get the you know, those declassified space telescopes, which are like Hubble class telescopes. That just, you know, they don't need them anymore because they're just not good enough. You know, and you get a sense that there is a, you know, you see launches coming out of Rehnberg, that there is this vast, still military space complex that is like an iceberg that we don't even see. Yeah,
for sure. And I don't even really know. I think that's the point, is that nobody really knows what's going on with the military space programs. Like the X-37B, I would love to know why that thing is just in orbit for a year.
What was it doing up there?
Military stuff that I feel like we shouldn't even hazard a guess at, because, you know, lasers might come down from space and kill us. But no, there's definitely, and it's also not like, you know, NASA was created and then there was this burgeoning human space program, and then all the military space programs died. Like, the military was still very involved in early NASA. You know, the Air Force supplied the Titan and the Atlas missiles, and the Army supplied the Redstones, and then, you know, once von Braun's group was brought into NASA, it was still that Army-based group that was supplying the Saturns, and they're still using military routes of the missiles and stuff. And you know, the military had its own space program for a long time. The Air Force kept trying to compete with NASA with things like Dinosaur, my favorite, and the Manned Orbiting Laboratory, also amazing, that never got off the, so many bad puns, got off the ground because they just couldn't compete with NASA. But the military has always wanted a foothold in space. And right in the wake of Sputnik, the U.S. Air Force jumped on this really hard and had this program that I've written a very long blog post about. It's not that long, but it's still rather long. The Man in Space program, which was the Air Force's plan to militarize the moon by 1965, and it was this like massive program to send people and animals to the moon, around the moon, militarize cislunar space, and eventually land and do all these things, as much for military gain as for international prestige. So this was something that the Air Force thought, we go into the air, we'll go higher and faster, and we'll get into space, and it's going to be our thing. We're going to win it.
So we got some questions from the viewers. Let's see. I lost them. A lot of people saying they are really enjoying the book.
Oh, thank you. I'm so glad.
G-Man wants to know if you mention any conspiracy theories in there.
No. Conspiracy. I don't know if we can like jump into the comments, but you mean conspiracy theories about the moon landing?
Well, just kind of in, you know, sort of in historically, you know, conspiracy theories, or even things that maybe people don't know so much about.
Right. No. And I can't even think of one from the era that would have made it in. So no.
I had some questions, and now they're gone. What? I don't know what happened to them.
Okay, I see one from Linda. Ooh, I'm going to mispronounce her last name. Linda Sadiq. I hope I pronounced that right. How difficult was it to get details on von Braun's life and work in Germany? There isn't too much about von Braun's early life because it is really hard. I don't speak. I speak very, very limited German, and it's mainly like, what size shoes do these come in? You know, workable German, so not rocketry German. But von Braun is one of the people who has been chronicled to death, and there are so many people who have taken pains to dig out these details, and this was one of the areas where I did have to rely very heavily on scholars who have done a lot of really good work in Von Braun. So if you are looking for that, my favorite book, Michael Neufeld wrote a fantastic biography on Von Braun. It's about this big, but it is fantastic. And he's done a lot of scholarly work, and there's a lot of people kind of who are with the Smithsonian now who've been kind of digging out a lot of that stuff, and they're all German speakers, so that's where I got a lot of those details. But one of the best sources, I should tell this. My friend Francis French, who some of you may know, wrote In the Shadow of the Moon. He had a correspondence with Werner's brother Magnus von Braun in the 90s, and he recounted for Francis in a letter what happened the day that he was sent out by bicycle to find the American soldiers and surrender to them. And I have his retelling of the story, 50 years later, but it's just such an interesting thing where he very candidly says, I mean, he's quite old at the time, he just says, I was the youngest, I was the least smart in the group, I spoke the best English. Basically, I was the one that was able to die. So they sent me out there. And it was, he describes it as like really tense and terrifying, and as soon as they figured it out, it just became like night and day. Like they were just so nice to them and so welcoming, but it was just so interesting to have that perspective weigh in on the narrative, which is really neat.
Guido Bieber wants to know if you're going to be doing an audiobook read by you.
I'm not. There is an audiobook, and it's not read by me, which is fine by me. I actually did ask my publisher about this, and apparently because it can take up to 2 weeks to record an audiobook, and they can't pay an author more to sit around and read the book, they generally hire a voice actor, and I heard a snippet of it. I actually have some copies of it, like physical audiobooks, so I didn't even know were a thing anymore. But it's a woman voice.
On cassette tape?
No, on CD.
On Audible, yeah.
But I mean, like digital version, I did not expect to be able to like go into a store and buy a CD of the audiobook. So, yeah.
So, what are some of your favorite ideas that von Braun had, had come up with for the future of human spaceflight, whether or not they were implemented?
I think some of the most incredible thing about von Braun's early ideas, there isn't one that really stands out to me so much as the magnitude of his ideas are always kind of amazing. So one of the earliest ideas he had was his Project Mars, which was the first mission he wanted to send to Mars. And it wasn't like an Apollo kind of thing where like you do recon with some robots first and then you send a small crew to like check it out and then you sort of gradually build it up. No, he was like bam, right off the bat, 70 people. And it was just this massive thing. I think it was 100, I might be getting my numbers wrong because I haven't looked at the details of this in a while, but it was something like 150 launches. Oh, my video froze. Did I freeze for you guys?
Nope, we can see you.
Okay. It was like 150 launches of a reusable launch system to build this spacecraft and fuel it, and then 70 people would be on board, and it would be not a flotilla, obviously, because they're not floating, but like in my head, it's like a pontoon of 10 ships going to Mars at once, and then there would be like the first guard of the landing people would go, and like they would land. And this is when they assumed at the time that Mars's atmosphere would be thicker, so they could land with a winged vehicle on a runway. So they were going to land at the poles, assuming that it would be nice flat ice sheets like we have on Earth. Land at the poles, and then take all the building supplies to the equator and build a runway for all of the other vehicles to land. And then everyone else would come down. I think 20 people would stay up in orbit doing orbital reconnaissance, and the rest would just kind of hang out on the surface for 500 days, and they'd all go home. And it was like this is how he wanted to do Mars. I mean, nothing was halfway with him. His space station wasn't, not to say that the ISS isn't awesome, but it wasn't a little can and then add. It was a giant wheel right off the bat with 6 different, an infirmary, a botany place, a place to relax. Like it was just all the way. Like, and then from this massive orbiting space station, you'd have like little things going to the moon all the time. It was just like 0 to 60 in half a second. It was just great. These ideas were huge.
Okay, so we talked about your book, and but as you said, this has been like a year ago when you actually delivered the manuscript. So what are you working on right now?
The next one.
You doing another book?
Yeah. Oh yeah. Oh, come on now. I'm a writer. This is like as stressful as it was in the final product, and like giving in the manuscript, I have to say, was one of the most terrifying experiences of my life, because I realized that I'd spent 5 years of my life developing this idea, and I'd moved across the country. I had like just moved across the country on my own, and like my whole life had changed, and I was like, this is like the little baby that came out of that, and then people have to judge it, and it was terrifying. But then I realized that it was the most satisfying thing ever. So, I don't have kids, but I feel like this is what parents feel. I don't know. But when I was writing it, I mean, everybody who kind of half jokingly, I want to say, angry tweeted at me that I stopped before all the good stuff, like the actual spaceflight. It's because I want to pick the story up, and I have another thing that I want to do with the next part of the story. So I am working on that.
You could write a whole book just on that Mars mission.
Oh, you could do. I mean, there's definitely a book that's half in my head about Mars too. Not just sort of like what we know and the history of Mars exploration, but like going back to the crazy ideas people had in like the Victorian era. Stuff is really fun. So I am working on a couple other book projects right now, just in the phases of kind of getting proposals together and getting kind of the like logistical details, like a publisher sorted. So that's happening. What else am I doing? My blog is still going. From way back in the day, Vintage Space is on Popular Science now, and that's kind of like my internet baby, because it's like the place where I get to play with all the weird ideas. Like today, I have to finish it up still, but we're talking about the lunar module ascent stages. So I just get to talk about this little legless bit for a while. And that has spawned the YouTube channel, which is actually doing quite well. So that's kind of the other thing that I am devoting a lot of my energy and time to right now. And the other big thing I'm working on is Dnews. I'll plug for Dnews there, which is, some of you guys probably know it. Discovery Channel's little daily science news show where I get to do anything that is usually not science, like conjoined twins and what are some weird stuff I've done? Like, I don't know. I've done some of like the strangest stuff. They're just like come up in meetings. Like, I can't remember. I've read, they don't stick out apparently, but so I'm working on a lot of that stuff, and I've got some other projects in the works that I can't talk about yet.
Well, then you're gonna have to return when you can talk about that.
Yeah.
So where can people find out more?
You can find out more. The best place to there's too much going on. The best place to find kind of daily updates from me is probably on Twitter. My handle is AST Vintage Space. It's just my initials in Vintage Space. It's not like a weird science term, because people ask me about that a lot, weirdly. I also have I have an author Facebook page. If you just search for me by name, I do post a fair bit of stuff there. And my YouTube channel, which is just youtube.com/vintagespace for weekly videos. And any of those things, you can comment there or tweet at me, and that's kind of a good place to find it. And the YouTube channel has a link to the blog, because the blog link is really hard. But if you Google Vintage Space, you'll find it. Yeah. It's like popsci.com/blog-network/vintage-space.
Okay, well, Google Vintage Space.
Yeah, that's exactly why.
Exactly.
Yeah.
And one thing that you have done, which I think is just an absolute treat, is you live blog the Apollo missions. So
yeah, that's still happening.
I know. So if you want to sort of like really just simmer in space history, whenever there is the anniversary of an Apollo mission, they're super entertaining to follow, and I think you should definitely watch that.
The next one, because there'd be way too much. I have to have like a separate account for every mission if I did them every year. But I do 45th anniversaries. So Apollo 14 splashed down the 9th a couple days ago, and Apollo 15 launches on July 26th. It's got a deep space EVA. It's got a lunar module or a lunar rover. So I'm going to be live tweeting that. That'll be fun.
Maybe the 5th anniversary of Curiosity or something. That'd be fun.
But that would take like 7 minutes. You know what I mean? Like I could just like tweet phases of the descent and be like, yay! It's more fun to. My favorite thing about the Apollo live tweets is figuring out the personalities of the astronauts, because you get a sense of like especially my favorite is when they get to the moon, they see it, and they start like they just turn from like methodical pilots and kind of cursing flyboys into poets, and they're just like listening to them or reading the transcript of them just trying to put into words what it feels like. It's like you get a sense of the human element involved in this, and it's such an interesting way to preserve it. So.
Well, thank you for taking the time to speak with us. Thanks for everyone who hasn't already. Go out and buy one of Amy's books.
I'm also selling signed copies on my website if anybody actually cares about that.
Yeah.
My shipping time is super long because I have to get the books from my publisher, sign them, and then figure out, especially international shipping with customs is becoming a bit of a problem, but they will get to you. So you can buy them on my website. It's amyshirateitel.com and /shop. You can find it there. But yeah.
All right.
Available
Well, keep us
everywhere.
posted, and we'll
Thank
see
you so much.
I'm sure we'll see you soon.
Yeah.
Thanks,
thank
Amy.
you for having me, letting me rant.
No problem. Anytime.
Hi guys.
All right, so Morgan, let's go on with the big news, of course, the one that made one of the biggest days on Universe Today this week. We found gravitational waves.
That's right. This wasn't just the biggest news of the week or the biggest news of the month. This was the biggest news to come out of astronomy in years. And this was the actual first direct detection of a phenomenon that we'd received indirect information about over the course of the last few decades, and that was gravitational waves. And these were detected at an institution called the Laser Interferometer Gravitational Wave Observatory, or LIGO for short. And they announced yesterday that back on the 14th of September in 2015, they discovered for the first time the actual signal of a gravitational wave. And to understand sort of what this means and where it takes us, we have to go back in time. We have to go back exactly 100 years to Einstein's general theory of relativity. And what Einstein said, amongst many other things with the general theory of relativity, was that space and time are linked together in something we call space-time. And massive bodies, things that have a lot of matter in them, things like the Earth or the Sun or other stars, they actually warp the shape of space-time. And that warped shape gives us the gravity that we feel today. And if you have an object that is warping space-time while it's accelerating, then you can release what are called gravitational waves. And in fact, almost everything that's in motion in space is emitting gravitational waves. The Earth emits gravitational waves continuously as it orbits the Sun, because going around in a circle is a form of acceleration. But the more massive you are and the more rapidly you're accelerating, the larger the magnitude of the gravitational waves emitted. And what this observation tells us is that about 1.3 billion years ago, a pair of black holes were orbiting each other. One of these black holes had a mass of about 29 times the Sun. The other had a mass about 36 times the Sun. So we're talking about very, very large objects. And as they spiraled into each other on a collision course, they began to spin faster and faster and faster, and this released large gravitational waves. And when they smashed together, they formed a black hole that was 62 times larger than the Sun. Now, if you're quick, you'll realize that 29 plus 36 is not 62. It's 65. And that's because three solar masses of energy was released during the collision of these black holes in the form of gravitational waves. And I don't mean 3 times the amount of energy being put out by the Sun. I mean if you took all of the energy in every single atom inside the Sun, that would be 1/3 the amount of energy carried off by these gravitational waves. A different way to look at that is that for a brief moment, the power carried away by these gravitational waves exceeded all the power being emitted by all the stars in all the galaxies in the observable universe. This was an incredibly powerful event.
That's amazing to think about. We talk about black holes and we say that nothing, not even light itself, can escape them. That that all pathways into are heading into the singularity of the black hole. Light, matter. You throw any matter. We've done a bunch of episodes about this. That you can't do anything to a black hole, and yet the thing that gets out is the gravity. And during these collisions, solar masses worth of gravity are actually escaping, and they're coming out of the mass of the black holes.
That's right. So we know gravity has to escape the black hole, otherwise nothing would get sucked in to or pulled in to the black hole. But the question sort of then became, once the theory pointed us in the direction of this is something that probably exists, the question was, well, how do we detect them? And to detect them, we actually had to look even farther back for the experimental technique that we use, and that's called interferometry. And interferometry is a method of making measurements on the smallest possible scales. And this is important because at the Earth, the disturbances caused by these gravitational waves shrink and expand space by a tiny, tiny fraction of an atom's width. So we're talking 1/1000th or 1/10,000th the width of an atom. That's how much one of these huge waves passing through the Earth shrinks or stretches the Earth. And so the way we do this is we use lasers. Lasers are the solution to everything.
Yeah, of course.
We shoot lasers down these really long tubes. And at the end of the tube, there's a mirror that splits it off in two directions. And these lasers move at right angles to one another. And then they bounce off other mirrors, and they come back, and they recombine in our detector. And if one direction is a little bit longer than the other, then the sensor realizes that the light from the lasers is a little bit mismatched. And so as this gravitational wave passes through, it stretches or compresses one direction of the laser without affecting the other direction. And this leads to detection. But you can imagine how sensitive this needs to be in order to detect something that's changing a thousandth or a tenth of a thousandth of an atom's size. And this means that it's super, super, super easy to perturb what's going on. And it's often said that slamming a car door a mile away from LIGO is far more powerful than the effect of a gravitational wave. And so to combat this, they have two stations located in different parts of the world. And in order to have an actual detection, they need to see the same signal at the same time from both centers. And that's what happened for the very first time in September of last year. And we should say this is only after more than a decade of searching. They found nothing, and they had to advance their technology, increase the sensitivity, and they were just starting to try again. And they're sort of like the Large Hadron Collider. They're going to be ramping up their sensitivity over the course of the next few years. But right away, they got lucky.
Yeah.
And to put this in context going forward, this is, the fact that gravitational waves exist is a big deal. But we also already had a pretty good amount of indirect evidence suggesting this was true. The fact that we can detect gravitational waves is what's the enormous advance here. Because virtually everything that we know about the universe has come to us through light. We catch it as X-rays or gamma rays or optical light or infrared or ultraviolet, but it's all light. And places that light can't get to are places that we've not been able to understand the universe. Places like inside a black hole, or the time right after the Big Bang, when the universe was still too dense for light to travel. And now that we can detect gravitational waves, we have a whole new, completely different way of interrogating and studying the universe. And it's going to open up our ability to investigate these phenomena that we've never had any opportunity to investigate before.
Yeah, I mean, as you said, right, like that when you imagine a singularity at the center of the event horizon of a black hole, and you collide two of these things together, we can only see the light from the outside, and none can escape, and therefore what actually goes on in those interactions is a complete and total mystery. But with the gravitational waves, it's possible that scientists will be able to see them circling each other within the event horizon, try and get a sense of the actual size and scale of the singularities themselves. Now it's just a matter of scaling up the level of detection, getting a much better sense, and seeing how quickly things, how quickly do the waves pass, or how slowly? How do they distort space as they move past? So, I think this really is a whole new way of us, being able to peer out into the universe. It's an astonishing accomplishment, and one that, is, I hope, goes into the Nobel Prize department. I mean, it's phenomenal.
Some just asking in the comments section, it's essentially a new way of seeing the universe, and that's exactly the way that's being described. exactly what it is. So imagine that for years and years you can see someone but you can't hear them, and now all of a sudden you can hear them and you can see them. It's a new way of looking at things, completely new sight for all intents and purposes.
Yeah. Yeah, just
already from this first detection, we've learned a lot about the ways in which these gravitational, or the gravity behaves as these black holes are merging. You know, we have this one little blip, and we can measure the mass of not just one, but two black holes. That's something that in the past has been very challenging for us to do. We can estimate their distance from us when this event happened, the direction in the sky that this took place. All of these information just from one little blip, actually before they had even intentionally turned on the instrument. They were still doing their engineering tests when they made this discovery. And that's really promising for what could be a wealth of detections and information about gravitational waves in the universe coming to a theater near you.
You don't need clear skies. You know, you don't need. You know, you can put a whole universe's worth of mass in between you and the gravitational wave, and it doesn't matter. So, you know, this first one is just that, you know, that first detection to know that the method works. Now it's a matter of scaling up the level of sensitivity. Space-based interferometer, you know, space-based detectors, far more sensitive ones. The sky is the limit. Fantastic. So I hope now I want to let people know that we've got a really great series on Universe Today that was written by Marcus Plossel, and he did three articles in the last 2 days about this incredible depth about what are the sources of gravitational waves, just how the detectors work, and sort of the underlying science. And they are three articles that I'm really proud to have on Universe Today this week. So if you really want to kind of dig deeper, please, you know, I don't normally shamelessly self-promote Universe Today, but this is the week that you should come and check out the site because we've got these phenomenal articles there. And we could talk about this for days and days and days, and we will. I think we're going to be dealing with the after effects of this for quite a while. But Jolene, why don't we talk about? Let's talk about somebody maybe or maybe not getting hit by a meteor. And just to let you know, there's a problem with your audio. So if you can just.
Okay, how am I sounding? Do I sound okay now, or am I awful still?
It just sounds a little.
It's just my
weird.
laptop, so I don't have like any handy microphone that I can adjust or do anything with.
All right, we'll have a
Just start
chat
waving.
after the show.
Okay, awesome. All right, start waving frantically if I go out, and I'll do something. Yeah. So anyway, last week reports came from India that a man was hit and killed. A bus driver was hit and killed by a meteorite. And if this were actually confirmed, it would have been the first case of someone actually getting hit by a meteorite or getting killed by a meteorite. Because actually, in Alabama in 1954. A woman by the name of Ann Hodges was apparently taking a nap on her couch, and a 9-pound meteor, which I guess is about the size of a softball, came blasting through the roof of her house, smashed into her radio, bounced, and hit her in the leg. So we do have confirmed cases where people have been hit by meteors. No one's ever been killed before. And astronomer Michael Reynolds said that getting hit by a meteor, killed by a meteor, same thing essentially, would effectively be like getting hit by a tornado, lightning bolt, and hurricane all at once. So pretty rare, to say the least.
So make sure I can see what's happening as you turn your face away from your computer. It's starting to cut off the audio, so make sure you don't move your head ever again.
Okay, I'll look straight ahead. I'll be like half robot here. Okay, yeah, fantastic. So anyway, though, so this would have been cool. I mean, not cool. My thought on that was that it would have been a cool way if you have to die. Interesting way to go.
What a way to go! Yeah.
Definitely, yeah. Certainly not cool for the man's family or anything like that. That's not what I meant. But NASA came out and said that based on what they have seen, the evidence is not consistent with an actual meteorite. So it seems that this individual is not actually hit and killed by a meteorite. They said that the fragments that were recovered first were cool, and if you think about stuff blasting through our atmosphere, the fire that's usually associated with that, we get lots of heat. That's not what we saw in this case. That's the idea that it wasn't actually a meteorite. Also, the samples of rock appeared to come from Earth, so again, not a meteorite. And they said that based on the images, their analysis of the explosion, it did seem a lot more consistent with a bomb, not a meteor blast.
So a bomb or somebody threw a rock at a bus driver.
And exploded tons and tons of windows. Maybe.
Okay,
probably
okay.
not a rock.
Okay, so a bomb blew up and a chunk of shrapnel was a rock.
Yeah, I mean, so I don't know where they recovered that rock from. It could have been, just nearby, something they might have suspected to be a meteorite, but it turns out that object that was recovered was just Earth rock. It's consistent with Earth rock. So yeah, but it was a pretty notable blast. There were 3 other individuals who were injured in this. So it was someone like throwing a rock and hitting someone. It was.
Right. Okay, we got a bunch of stories. Let's move on. Morgan, let's talk about the NASA budget proposal. You can be Casey Dreyer for today.
This will be a quick one because this is a pretty meaningless budget proposal. So on Tuesday of this week, President Obama released his final budget request to Congress to fund things in the fiscal year of 2017, and it was promptly ignored by Congress. But it does give us an indication of the direction and priorities that NASA will have in the coming year. And once again, this was a budget that indicated that the president and the top brass at NASA aren't terribly fond of planetary science. Every area of the NASA budget received an increase in funding except for 2. One was planetary science, the division that funds things like Curiosity and Cassini and New Horizons, etc. And the other was the Space Launch System, or SLS, the large next-generation rocket that's designed to carry humans beyond Earth orbit and to launch planetary science missions to the outer solar system. Both of those received pretty substantial cuts to their budget as compared to what was given by Congress last year. And that is really sort of the story here, is that this is at best a guideline for what Congress, who will actually set the budget, should follow, and at worst sort of a partisan pandering of exactly what the president would like to see happen, even though much of that isn't likely to take place. And it does get the story started, though, in coming forward into the year about what will happen. And where these budgets can actually be important is on the smaller programs. So these big top-line budgets, not that important. But the details reveal sort of NASA's intentions for the coming year. And what was different about this budget from the previous ones is it doesn't attempt to kill off some of the older missions. Past budget requests had suggested removing funding for the Lunar Reconnaissance Orbiter, as well as removing funding for the Opportunity rover on Mars. And this budget maintains funding for both of those. And that suggests that no matter what the final number assigned to NASA by Congress and ultimately signed by the President, there's not the intention within the agency to pull the plug on any currently operating missions.
But one might get delayed.
That's right. So we know already that the InSight mission has been delayed from the planetary side, and that's because of an instrument failure. But we also found out through sort of a slip of the tongue from a NASA administrator, a NASA official, excuse me, this week, that the human spaceflight missions are also likely to be delayed. And the mission that NASA is working on is the Asteroid Retrieval Mission. This is the plan to go out, scoop up a near-Earth asteroid, put it in orbit about the moon, and then send humans out to bounce around on it. And the robotic portion of this was supposed to launch aboard the SLS in 2020 to go out and begin pulling that asteroid back towards the moon. This now sounds like it's unlikely to take place before 2023. So that's a 3-year delay. And the indication here is that no one in NASA is particularly gung-ho about the asteroid retrieval mission. This was sort of President Obama's notion of where the space agency was going to go before going to Mars. But it's never really had a clear direction or a clear mandate. And at this point, many people would suggest that NASA is just trying to sort of limp forward until a new president enters office in January of 2017, in which case its priorities are likely to be completely shuffled around.
I have been doing this job now long enough that I have watched this same thing happen over and over and over again. And it is literally, like, I remember President Bush, I remember, I'm trying to think, Clinton was in office when I started. So I remember we're going to go to Mars. No, we're going to go back to the moon. No, we're going to go to Mars. No, we're going to go to an asteroid. No, we're going to go back to the moon. Like, I've watched each one of these, and we talked about this last week, that nothing's going to happen until there is some kind of long-term, some way to come up with a long-term strategy and stick to it over that long term. Otherwise, how do you maintain some kind of human exploration program where every 4 years everyone's mind changes, especially depending on what's happening with the economy, what's happening with other kinds of funding priorities, wars, things like that. So this does not surprise me. I would be surprised if anything else happened.
Now, this will be a challenge for the next administration to try to chart a path forward that is, if nothing else, more directed, and has, as you were saying last week, a series of clear, achievable objectives that get them going in one direction and build up some momentum. Because once you have that momentum going, it's more difficult for a future leader to come behind and totally redirect things. But the Asteroid Redirect mission never actually got off the ground, to steal Amy's phrase, and thus there was nothing pushing against canceling it. There was no work had been done.
Let me give you an analogy, which is, in my house right now, I have all the fixings for pancakes, right? I got milk, I got butter, I got flour, I got all this stuff there that if I wanted to make a batch of pancakes right now, I could do it. And that's because I went out and I shopped and I got all these things and I've made sure they're in the house in ample supplies that I can make pancakes. So right now, if I need to like, hey, what does everybody want for breakfast? And I have to go out and go to the store and buy all the raw ingredients and bring them all back, and it's going to cost me a lot of money. I'm probably just going to make some eggs. So no one's getting pancakes. And this is the analogy, right? Which is that you need to have just these flexible capabilities across the whole system that if what NASA decides to do is like, hey, let's go back to the moon. Well, why not? Because we've got a great big launcher. We've got, a proven platform being able to land on the moon and take off again. We've got, we know how to keep humans alive in space. We know how to protect them from solar storms. We know how to replenish fuel supplies in space. All these kinds of things. All of these questions need to be worked out. And every time that you say, we're going to go to the moon, you put off all those other little capabilities, all those little pieces to try and go after that great big goal. And then that goal falls through, and you never did all those little pieces. You never went out and got all the raw ingredients for your space pancakes, and instead, you just had this kind of empty wish, and it just carried you through another 4 years until the next mission. So anyway, we're going to see this again and again.
You should take that and do an open letter, Fraser's thoughts to NASA.
I have. I did an episode. I did a whole episode on YouTube, just me saying that. And I even had a chance to talk to a bunch of people at NASA, and the gist was, you're right. Right? But here's why it's a problem, I think, is that you've got all these people who worked on the space shuttle, and you had, people in every single congressional district in the United States, and every state has some extent, and these people were employees, and they needed to be put to work doing something, and that's SLS. And so if you take the space shuttle crew, the space shuttle workers, they're all working on SLS now, because you can't just fire all of those, lay off all those people. You have to keep them working on something, and SLS is a reasonable goal as any. We need a heavy, I say we, I'm Canadian. You, Americans, need a heavy lift vehicle. So it makes sense to shift to that, to that capability.
And it's transparently done. SLS is the space shuttle main engine on steroids, and they just happen to say keep churning these out, and we will build a rocket around them for some nebulous future use.
Everybody keep working. Nobody gets laid off. Voters don't get laid off to change governments. So I think that, and in fact, having the SLS makes more sense than the space shuttle. So it's not a terrible idea, but I would just love to see more capability, just more general capability, so that at any point NASA could go and grab a piece of an asteroid and bring it back, or dock, or anyone watch The Expanse yet? Oh, such a good show, and it's just like, oh, that's what I want. That's the future I want. Anyway, I've got the whole chat group thinking about pancakes now, so I'm going to make some. Let's move on to I think we've got 2 more stories, and then we should wrap this up. Let's talk about the James Webb Space Telescope mirror, and then we'll get on to Jolene's last story.
So here's some good news coming out of NASA, and that's that the main mirror assembly for the James Webb Space Telescope is finally complete. Now, you probably have seen pictures of this mirror. It looks like this sort of futuristic honeycomb structure built up of 18 individual mirrors. And this is going to form the 6.5-meter aperture of the James Webb Space Telescope. The tricky thing here is that that's bigger than any rocket is wide. And so in order to get JWST into space, you have to fold that mirror up as part of the, and then in space successfully unfold it. And that's led to extreme complexity within the telescope and led to a series of scheduled delays as they were building it. But with the main mirror finally installed, they're on schedule to meet their mid to late 2018 launch window, and then James Webb will really revolutionize our view of the universe on top of what Hubble has already given us.
Yeah, finally a practical use for origami. When you look at how that telescope is going to work, it's kind of amazing. And this is one of those big budget sinkholes right now. But if we get the James Webb rolling and peering back to the edge of the universe, it's going to be an amazing time. Speaking of things in the universe to be peered at, let's talk about hidden galaxies. Jolene.
Yay! So recently, astronomers used data from the Parkes Radio Telescope to find, well, they saw 883 galaxies that are about 250 million light years away. And about a third of those galaxies that were never seen before. Now, this in and of itself isn't too terribly invigorating or exciting. I mean, it is cool, but obviously we know there are tons of galaxies out there that we haven't seen yet. There's lots of dust and stuff in the Milky Way, lots of stars, so it's hard to see through this. They have a multi-wavelength telescope, I believe, and so they were able to see this, and they're able to explore the sky a lot faster. And of course, as technology progresses, we're only going to get more and more efficient at this. But the reason that this is cool is because of something known as Great Attractor. So basically, really briefly, we know the universe is expanding because when we look at galaxies, we see that they are moving away from us year by year, and they're doing so faster and faster and faster. However, the expansion of the universe isn't completely uniform. So obviously, the sun isn't ricocheting away or flying off into the cosmos away from the Earth. We're not going off. So you have these specific areas where there's large concentrations of mass, and the things are moving towards one another. And that's essentially what the Great Attractor is. There are hundreds of thousands of galaxies that are all being pulled towards this specific region in space, and we don't exactly know why. This was first observed back, I believe, in the 1970s through observations made of the cosmic microwave background radiation. And the latest observations of these galaxies helps us better understand where large concentrations of galaxies are and what could possibly be pulling this mass of galaxies towards this specific direction.
I wish we had a radio astronomer here to be able to jump in, as opposed to just chatting with the people over on the discussion. But hi, Nicole, that's you. Right. So I mean, this idea of the Great Attractor, right, which is that, as you said, back in the 70s, astronomers detected the galaxies all just kind of sliding towards something, but that something was hidden by the dust of the Milky Way, and you can't actually see through the disk of the Milky Way, and so they assumed that it was just a whole pile of galaxies on the other side of the Milky Way, but they never had the tools to be able to see through it. And then thanks to infrared astronomy, which lets you see through that dust, they were able to sort of see more and more of what's on the other side of it. And now with these radio observatories, they were able to get a much better accounting of what's going on the other side. Turns out it's not, the name, right, the Great Attractor. People, once again sets their imagination rolling, and they're just kind of imagining, I don't know, like aliens or some kind of kind of drain from the universe, but no, just a lot of galaxies that happen to be on the other side of the Milky Way from us.
And since we're talking about gravity and all that fun stuff today, it's important to remember too that gravity isn't necessarily, it doesn't pull something towards it. It's ripples in the fabric of space-time that causes these dips, and then we follow those paths and so on and so on. So definitely not aliens with some big type of device that's yanking us across the cosmos.
Yeah,
sadly, that would be awesome, right?
Or a drain that's letting out everything on the other side of the universe.
Yeah.
No, but it's cool. I mean, just that what was one of these big mysteries is now they're getting to a place where they can actually narrow down and know what's going on.
Yeah.
So.
Yeah, well, it's like the face on Mars. I mean, we were fairly certain it wasn't really a face on Mars, but then once we got the awesome super telescopes that can actually take images, like, no, look, it really is just fun.
Just a rock. Just a hill. Cool. All right. Well, let's wrap up the Weekly Space Hangout for this week. Jolene, where do people find out more?
At Futurism. Hooray! Google Futurism, Twitter, Facebook, all that fun stuff.
Yeah. And Morgan, where do people find out more?
Last day of February. It's a leap year this year. You can come say hi at Astronomy on Tap, Colorado. We'll be having it over here in Boulder this month. Say hi. We'll talk some science. Otherwise, you can follow me on Twitter at Morgan Rehnberg, or visit my website, morganrehnberg.com.
Fantastic. So I want to do one plug, which is, as you know, you're watching my YouTube channel. I do these shows, but I also do The Guide to Space. The next episode of The Guide to Space, coming out Monday, I think, is a collaboration with me and Dr. Paul Matt Sutter, who is often a guest here on this show. And we discussed this idea that black hole singularity and the Big Bang singularity both use the word singularity. What's up with that? Are they the same thing? Did the Big Bang start from just a really big black hole? I don't know. You'll have to stay tuned and find out. So if you haven't already, click subscribe to this channel, and when that episode goes live, you'll be able to watch. It's actually a two-part episode, because I then ask Paul, or here's a weird thing, which is that if you take all of the mass of the entire universe and you turn it into a black hole, it would have an event horizon the size of the universe and a density of the universe. So are we just living in a black hole, and how could we tell? So those two topics are covered in a special two-part, mind-bending episode of The Guide to Space, and that's going to be coming out early next week. So if you haven't already, make sure you subscribe. Attack wants to know why we stream at the same time as Tony Darnell. We should do some kind of collaboration and just stream at the same time with them. Therefore, you don't have to choose. Okay. So thanks everyone for watching. I want to, as always, remind you to go and join the Weekly Space Hangout Crew. This is the fans that help us really produce this show, and we couldn't do this without them. So do a search for WSH Crew, and you'll be able to find all of the places and coordinate with them. Thanks again to Jolene and Morgan. Thanks to all the fans for watching and commenting. It's hilarious to watch. And thanks to Shira Teitel for being our special guest this week. All right, we'll see you all next week, everyone.